How well did your design meet the specifications of the performance test? Design performed perfectly as outlined by the specifications of the performance test. First, we had designed the lever that had been used to deposit the tray in a previous performance test to also be the correct height to be able to hit the ice cream lever. Additionally, we had to design the robot to be able to attach a QR code on top to be able to read the RPS values that would give us the correct ice cream lever to hit. Lastly, we had designed the burger rotating claw to be at the proper height to also hit the final button.
Did your design perform as expected? As Pete said, the design specifications were met with accuracy and precision, but there were problems on the software side. For instance, the ice cream lever is in the dead zone of RPS, so we needed to make sure that shaft encoding was super accurate so that it would go to the correct ice cream lever consistently. Another problem we had with the RPS was that it was hard to configure at times. We get our directions mixed up, and sometimes we would be too far from the pole, so it would take a long time to get there.
What are the strengths of the design, and what should remain the same going to the next performance test or competition? A few strengths of design include the multi-functionality of each of the parts. It allows us to have a lot less moving parts when we can combine things such as the tray depositor and the ice cream lever flipper into one arm, as well as the burger flipper being at the right height to press the final button. Additionally, another strength of the design was the height that the QR code was placed at. We purposely increased the height that our top bar was at because we realized it was not high enough. We added in a little spacer so that the QR code could be at the right height and therefore could read the most accurate RPS values that we could get. We're not going to need to change anything design-wise. We already have it all sorted out. However, we will need to adjust our software and increase the implementation of RPS in our code.
How can the design be improved for the next time the robot has to perform these tasks? As Pete graciously said, the hardware components of the design are perfect as of now, but the main changes that will need to be made will be in the software regarding RPS and further implementation of it to make sure that the navigation of the robot is more accurate rather than just relying on shaft encoding itself.
What problems did your robot experience, and what were the causes of these problems?
Overall, the team was pretty prepared for this performance test, but it wasn't the design that had the issues, it was more of the execution. So on the hardware side, everything will remain the same except the QR code. The main problem was just the software. There was many inconsistencies with the shaft encoding. For instance, when we had to turn to get to the ice cream levers, sometimes it would miss the ice cream levers by going in between each one. The main part with that we could fix for future things is just to pair RPS. As you use shaft encoding to navigate, it can use RPS to correct its position to make sure that it's consistent every time that it turns. Another problem we had was actually with RPS. When the robot was moving back down the ramp, it would take too long to get to the correct position because we kind of just relied on RPS to do its job. And with that, the pulses made the robot movement even slower, and that's not going to look good for the final competition. We're just going to improve the software side because the hardware side is completely fine. It's just the software that we need to increase the pairing with RPS and shaft encodings to make sure that the robot moves faster and more accurate at the same time.